Sweet. All right, so I'm recording now. So, all right, so on I'm going to use number 6 as our first example, okay, because we have the equation F equals ma, right? We're trying to solve for force, mass, or acceleration. These problems will give you one of those three, or two of those three variables, okay? In the first problem, we're going to solve for force. And then in the second problem, I'll give you an example. We'll solve for mass. And then the last one, we'll solve for acceleration. All right, so I'm going to leave this right here, and we will plug in as we go. So number 6, it gives the mass in grams, okay? So I'm going to read the question. It says, an object with a mass of 2,000 grams accelerates at 8.3 meters per second squared when an unknown force is applied to it. What is the amount of the force? Okay, so your question in the email had to do with the fact that I told you to move the decimal 3 times, okay? Yeah. Now, that's because something we learned in the beginning of the school year was a way to convert from grams to kilograms, okay? So if we have 2,000 grams, for these problems, the mass has to be in kilograms, okay? So I have to then convert 2,000 grams to kilograms. To do that, I do move the decimal 3 times to the left, okay? So did you learn this before? You could shake your head, yes or no? No? Okay, let me show you. All right, so I'm going to pull up a different board just so I can show you how to convert. Okay, so if I have 2,000 grams and I want to convert to kilograms, I have this little saying, King Henry died blank drinking chocolate milk, okay? That blank in the middle is for base units. Does that look more familiar now?
Yeah.
Yes? No? Oh, you're commenting. Yes. Okay, cool. So just to show you again real quick so you know what I'm talking about for sure. In the center right here, those are where our base units go. You get meters, liters, and grams are the 3 base units, okay? So in this case, we're talking about grams. So that means that I'm starting right here in the middle, and I need to go 3 to the left. So I go 1, 2, 3 times to the left. So to show you with my number, to not change the value of this number and to keep it, but to give it a decimal, I put a decimal right here at the end and it doesn't change the value. So now I can go ahead and move it just like I did up here at the chart, okay? So I go 1, 2, 3 times to the left. So then 2,000 grams actually is 2 kilograms. How do you feel about that?
Yeah.
Good? Okay, sweet. So if I go back to my other board, and we just changed this, this is going to be 2 kilograms. That right here is our mass, okay? So instead of 2,000 grams now, we have 2 kilograms. So our force is what we're solving for, so F equals, and then the mass is 2 kilograms. And then since these are next to each other, we multiply. The acceleration in the problem was 8.3 meters per second squared. That squared just belongs to the unit. Remember we learned that, I think, before we went for e-learning. So this right here, it just means that's the acceleration. So we have everything we need now. We say 2 times 8.3, and if you put that in your calculator, that comes out to 16.6, and then the way we measure force is newtons.
Okay. Yeah.
Cool? All right. So are you ready for me to move on to the next example?
Oh, yeah.
Yeah. Okay, cool. the next example we can do is number 11. So if you look down a little bit further on your page, it says an object accelerates 7.2 meters per second squared when a force of 4 newtons is applied to it. What is the mass of the object? Hold on. Are you still there?
Yeah.
Okay, sorry. My computer just did something weird. All right, so I'll say that again. Number 11. An object accelerates 7.2 meters per second squared when a force of 4 newtons is applied. What is the mass of the object? So if I have that equation, F equals ma, in this case, it gave us our force and it gave us our acceleration. We're trying to find the mass. Okay, so our force that it gave us is 4 newtons. And the acceleration it gave us was 7.2 meters per second squared. Okay, so now all we do is plug that into the equation and then isolate the m so that we can solve for it. So I have 4 newtons for my F equals, I don't know my mass, so I put m as the variable. And then I say times 7.2 meters per second squared. Do you know how to get this onto this side? Yeah? Go ahead and comment what you do. Yes, divide. So I'm going to go ahead and divide 7.2 meters per second squared. To get it off that side, I put it on that side, 7.2 meters per second squared. So now my m is by itself, and if I put this in the calculator, I get like this long number. It says 0.55555, right? So on the sheet, I'm letting you round to the 10th place because that's where I have all my numbers, okay? So that would actually round to 0.6. And then how do we measure mass? What's our units? Go ahead and comment for mass. Good, kilograms. So technically I'm gonna fix that and put kilograms between there. Cool?
Okay. Yes.
Yay. Okay, let's do the next one. I was gonna do number 18, okay? So if you want to turn your page over. Number 18 says, an object with a mass of 3.2 kilograms has a force of 7.3 newtons applied to it. What is the resulting acceleration of the object? So do I need to convert that mass?
No. Oh.
Oh, good, because it's already in kilograms, so we don't have to actually convert with that one. So F equals ma. Our mass is 3.2 kilograms, and our acceleration, or sorry, our force it gives us is 6.2 newtons. All right, so we plug that stuff into this equation and solve like we did before. So our force is 6.2 newtons equals a mass of 3.2 kilograms times, and we don't know acceleration. So we isolate again, the A. So how do we get the 3.2 onto the other side? Good. So divide 3.2 kilograms. That cancels out, 3.2 kilograms. And so our acceleration is this number divided by this number, which I put in the calculator already, so I was ready to help you. I think I did. Maybe I didn't. Did I think I switched problems. Did you notice that? I think I used the wrong number. This was supposed to be 7.3. What? Going to redo that. Sorry. The mass was 3.2. The newtons was 7.3. Okay, so let me go ahead and fix that. 7.3 newtons equals 3.2 kilograms. You said to divide to isolate. All right, that was my bad. I gotta, now I have that on my pre-calculations. This comes out to like 2.28, okay? So can you put in the comment what you would actually, that number would end up being after you round it?
Oh, that's one.
It was 2.28125. Or you can do the math and plug that in. Good. You rounded that 2 up to 3 because it was 2.8, so the 8 made that 2 go up to 3. So this is 2.3 what?
That's for 7.
Good. Meters per second squared, because that's the units that were used for acceleration. All right. How do you feel now?
Good.
Good? It's funny we did all this with you all somehow muted. All right. So are you good with everything? If you have any more questions, you can put it in the comment box. If not, I can pop off.
Okay.
So we would only do the rounding thing for force in the question, not the answer. Well, it's only, so rounding is where if you have more than one decimal. So if anytime you get a number when you calculate and it says like, 5.675, you have to actually go 5.6, okay, so 6 becomes 7. You only need one decimal place.
Yeah.
Does that make sense?
Yeah, but like to the one.
But for the moving the decimal thing, that's only when you are given the answer in grams and you need kilograms.
Yeah.
Is that what you were thinking?
Yeah.
Okay. All right. So yeah, if you get stuck at all again, just let me know, but I think you're good.
Okay.
All right.
Thank you.
Bye.
Bye.